Okay, now that we've seen how to look at a table and make some calculations to determine if that table could represent a linear exponential function, let's give this some more practice. All right, so number 2, as I look at my x values, I notice that my delta x is increasing by 1 each time. So I'm going to make a note, delta x is equal to 1, and that's constant. And the reason I do that is that allows me to use this trick up here of just comparing these consecutive y values. So I want to note that. And then usually the first thing I check is to see if it's linear, because I can usually do that fairly easily without a calculator. So before I break out my calculator, I'm going to check that first. To do that, I'm going to say, what is 10 minus 14? Well, 10 minus 14 is a negative 4. And then I'll go to the next pair of consecutive y values. So 6 minus 10 is also negative 4. So this here tells me that my function y1 is definitely not exponential. Okay, because if it was exponential, the difference between consecutive y values would be changing. Okay, but since it's not, that means my only possible answer left is maybe linear. Could be neither. But we're going to check and see if it's linear. So I'm going to keep subtracting the difference between these pairs. So 2 minus 6 is a negative 4. Negative 2 minus 2, also a negative 4. Negative 6 minus a negative 2 gives me a negative 4. And same, negative 10 minus a negative 6 gives me a negative 4. All right, so the difference between each pair of consecutive terms is the same, it's constant. So that means that y1 could be possibly linear. All right, I would like you to pause the video, try numbers 3, 4, and 5, and then we'll come back and give those a try together. Okay, so hopefully you gave those a try. Let's look at number 3. All right, so the first thing I'm going to look at is delta x constant? It is. So that's great. I can use this shortcut. And then the difference between 1/2 and 1. Okay, so 1 minus a half is 1/2. And the difference here, 2 minus 1 is 1. Okay, so these are not the same difference between these. So I know that it's definitely not linear based on that. Okay, so that means my possibility would be that it's exponential. So what I'm going to do then is I'm going to take 1 and divide it by 1/2 and see what that comes out to be. So let me make sure my calculator's in frame here. So 1 divided by 1/2 gives me 2. So it looks like we multiplied by 2. 2 divided by 1 is 2. Let's see, 4 divided by 2, I can do that one in my head. That's 2. 8 divided by 4 is 2. 16 divided by 8 is 2. And 32 divided by 16 is also 2. Okay, so we multiplied by the same thing here all the way across to get from one y value to the next. So our ratio was constant, which means that this could potentially be exponential. All right, number 4. So look at this, and I go, oh, I don't really want to subtract those fractions. So I'm going to start over here to see if it's linear. So the difference between 1 and 3, so 3 minus 1 is plus 2. 9 minus 3 is plus 6. Okay, so this one's definitely not linear. Otherwise, these two numbers would have to be the same. So let's try for exponential. We put some marks in here. So we're going to do 1/3 divided by 1/9. So I'll put that 1/3 in parentheses and the 1/9 in parentheses. Okay, so that would say we multiplied by 3. And then 1 divided by 1/3 in parentheses, also 3. Okay, 3 divided by 1 is 3. 9 divided by 3 is 3. 27 divided by 9, also 3. And then probably don't know 81 divided by 27 in your head, but that one's also 3. Okay, so since we multiplied by the same thing all the way across, this one is potentially exponential. Okay, if you weren't adding by the same number and you weren't multiplying by the same number all the way across, then it would be neither. So not linear, not exponential. All right, last one. Oh, we forgot to mark that delta x equals 1 here is constant. Don't forget to do that. And we'll do the same thing here. Delta x is also 1, which is constant. All right, so negative 9 minus 14. Or in other words, what's the difference between 9 and 14? That looks like a plus 5 there. Difference between negative 4 and negative 9, we added 5. Here we added 5. 6 minus 1, we added 5. 11 minus 6 is 5. And 16 minus 11 plus 5. So this one could represent a linear function.